I've been using the SuperPID on my CNC machine for a while now. It has worked okay, but there are a number of issues with it that leave me wanting a more sophisticated device. If you look at this, you can see that it uses an onboard LCD display. This is not a bad thing by itself, but as a result, I cannot look at the display most of the time. I keep the board together with the other electronics, so the only time I can read this is when I stand right next to it. Of course, there is not really much information on the display anyway. It displays the currently measured RPM and a progress bar of what I believe to be the firing angle of the triac as a hint of what percentage of delivered power is being used. Also, it has to be powered externally, and there is no proper e-stop relay. The P and I values are not tunable. There is no actual current or power measurement. There's no way to connect an external display. It uses screw terminals instead of spring terminals, and a number of other small issues. The one thing that I absolutely wanted to have was the ability to display currently used power, and there is no amount of patching that is going to make this board do that for me. So here is what I came up with. This is my first prototype board, and the features this board has is that there is a power supply here that can take power from the line, meaning that you do not need external power in order to get this to work. However, it can be powered externally via a USB plug here, in case you want this to operate even while there is absolutely no power on the line coming in. The core of the unit is a microcontroller that handles the PID loop and anything else that is time critical. There is an Arduino here with an OLED display, it's a color display, that displays all the information that is necessary. There are a couple of pots here in order to be able to change the P and the I variables. There are some setting dip switches, which I don't use yet, but they may be used for things such as enabling or disabling current limits, etc. Programming header, of course. And these terminals here are spring terminals. They do not need a screw. They can simply be pressed down and the wire gets plugged in, and then you let go and the wire stays in place. I like these much better because very often one puts some solder at the end of a wire, even though technically you're supposed to use a crimping connection, and the solder can creep. And what these spring terminals can do is even if the wire starts, the solder on the wire starts creeping, they will of course continue to exert pressure and make sure that there stays a snug connection. Also, you don't need a screwdriver for these. You just press, stick in and let go. So I like this much better than screw terminals. There's a relay here which can do a proper e-stop mechanism. And other than just providing power, this system also streams out serial data with the information that comes from the microcontroller, so that then a computer could display information such as current power used, etc. The information, of course, also gets displayed here, and I like this a lot. You can put a Raspberry Pi Zero here in place for the simple purpose of using the HDMI out. And with that, one can use one of these touchscreen HDMI displays, or perhaps an old computer display, or your 85-inch living room TV. Any of those things can then start displaying the PowerPID parameters, such as how much power is being used at a time. There are a lot of things I can do with this board that the SuperPID cannot. I can limit power. Of course, I can display power in real time. I can display all the parameters that I'm interested in on external monitors, and a number of other things. It also fixes the very awkward, I feel, way one has to do the external switch over for manual control versus computer control.